Hi there, welcome back. So today I'm going to show you how to calculate curve number from soil map. So we already have idea about this type of soil map, right? We downloaded this data from Soil Sargo website and we processed this soil map, and now I'm going to show you how to calculate curve number, because if you know the hydrologic soil group, it is in A, B, C, D, and then you need to calculate the number because the curve number ranges from 30, 40 to 100 or 99. So it depends on the curve number. If you want to see the soil property and if you want to use that in your loss function, if you want to develop any HEC-SMS model, you need to know the curve number for your specific watershed or sub-watershed. So how can you calculate that one? And if you need that, so what are you going to do? You have to be able to calculate that curve number, right? So now I'm going to show you how to calculate that curve number from the soil map, because I'm going to show you, see, if I open that table, you can see we have different soil properties. We are not going to focus on all of them. What we are going to do here, see, hydrologic soil group, we already have that, right? For each of this polygon, we have this different soil group, but we don't have the curve number here in this table. So I have to prepare that one. I'll show you, because we have this data already tabulated in US Army Corps of Engineers website, and you can even find it from different hydrologic information book, right? You can do that. It's published already there. And I'll calculate the corresponding curve number instead of D, right? So we know the hydrologic soil group for this specific area location, but what will be the curve number? Is it 80 or 90, or what is the value? And we need that specific value in our equation. If you want to use the loss method as curve number method, then you have to provide that curve number, and then you need to calculate curve number, right? You have to do that. So before going to calculate that one, I'm gonna just export and I'm gonna create a new project so that you can follow, right? What I'm gonna do is time I open a new project, a new tutorial, I create one separate project for it, right? So here within this folder, I'm gonna create a new folder called CN, or curve number calculation. Okay, and inside that curve number calculation, what I'm gonna do here, I'll just save my, okay, just gonna open it, and then I'm gonna add and file, personal, it will be shape file, and then I'm gonna save that as soils. Okay, I'm going to save this as soil curve number. So it will be, the curve number will be shape file. I'll put it that way. So I have that. I don't need that one. What I'm going to do, I'm going to open a new project, and each time I do, I'm going to create inside that curve number calculation, I'm going to create one new file geodatabase, and that geodatabase will be curve number. Okay, CN calculation. Then I'm gonna add this, so everything will be stored there, see, and it is gonna open a new one. And if it is this one, if I open the soil map, now I have access to this one. So it's pretty simple, right? And see, if I just wanna save my project, before saving that, what I do, I just click this one, store relative path name or path, right? And then I just save this as save as, and it will be inside my curve number, right? I'm just gonna go back, and here's the calculation of curve number, and I'm gonna save that CN calculation. And if I remove the part, extra part, and it will be AMXD file. So I have one folder. Inside that folder, I have the geodatabase. We have everything inside there, and we have only one file as shape file. So if I wanna show you what we have inside that table, we see we have different IDs, object IDs. We already have idea about this one, right? But the most important thing is that we have this hydrologic soil group. See, previously it was long name, but now it is short, right? So it is hydrologic soil group, ABCD, it is same. So we need to provide another column based on this column, or based on these values ABCD, right? We have different values ABCD, or C/D, or B/D, right? Whatever the value, will calculate that one. So we'll add one column at the end of this table, and we'll add the corresponding curve number value. Right, before that I'm going to export this table as Excel file. We can do that. We can click on our Arc toolbox as we did before, and then conversion tool and Excel. Right, we're going to convert from table to Excel, and let's see if we can convert it from table to Excel. And that's it. I'm going to select this soil, and it's going to take a while because it's a very big table, right? And then if I want to save everything inside this one, and let's see if it's going to export it or not. Okay, and then we'll open our table and we'll convert it to CSV, and we'll do some operation. I'll search the corresponding values of curve number for this hydrologic soil group, and then we'll do some operation there. Okay, let me find the values we have, curve number calculation and stress, and inside that one we have that table. Okay, let me just remove some columns from it so that we can follow. Right, we don't need this extra table. We're gonna extra columns, we don't need that. We need only that hydrologic soil group up to this one. I'm just deleting, control minus, and it's done. Even I'm gonna delete everything up to this one. We don't need, right, any of them because it is already there. I'm gonna just reduce the number of columns. So what we need curve number here, CN. Okay, so in order to do that, we have to find the values from website. Okay, how can I do that? If you go to Google and you can search for curve number table, it will give you this one, HEC, right, HEC SMS technical reference manual, and you can find these curve number values A, B, C, D. These are the soil groups, and you can see that these are from SCS TR technical reference, and then 55 table number 2 2A, and runoff curve number for urban areas, because our area is located in Houston, Texas. It is a city, right? It's mostly the urban areas. And we also have another table for cultivated agricultural land, so you can do that. And we also have another one which is the other agricultural land. These are the options we have, and we have another one for arid and semi-arid, right? So I'm gonna use that first one. So urban areas, and we have, see, we have different options here. The poor condition grass, that is less than 50%, and fair condition grass cover 50 to 75%. Okay, since in USA the city is also covered with grass and everything, I'm gonna select this one. Okay, this is the moderate or fair condition. Even you can use the other one, it doesn't matter. I'm just gonna show you how to calculate curve number from this table, right? If you know your area and the description of the area and the coverage or the vegetations or other informations, then you can even use that rows, it doesn't matter. Okay, I'm gonna copy that, and I copied it, and I'm gonna paste it there, and let me create a column here. Okay, we'll have this way. I'm gonna create a column or table, curve number, and I have A, I have B, C, and D, right? So these are basically A, B, C, D. I'm gonna just transpose this one. So we have A, B, C, D, but you can see that we also have B or D, and we also have another group C or D, right? We also have that. I'm gonna create the curve number for this one as well, and we don't have any other like A, B, or right, or other combination. We don't have that. If you check it, we only have A, B, C, D, or it is either B, D or C, D. So I have these two options, right? What I can do, I can even I can take the average between B, right, and D. How can I do that? I can just sum them up and divide by 2. That will be the average value. So I don't need that, right? Okay, I can keep it that way. It is also good. If I wanna get the curve number, these are my reference, then we'll fill this column, right? The corresponding curve number from this table. We need to do some operation here. You need to know this thing in Excel. You can use your code even in Python or in MATLAB or R to do the same job, but I'm gonna show you everything in Excel so that you can even follow. You don't need to have expertise in programming language, right? So here it will be, right, C plus D, and if I just make this as pretty simple, okay, I'm taking average of these two and it's divided by 2. Okay, so we have these values. We don't need this one, we already have. So what I'm gonna do, I'm gonna use this table as reference, and I have to fill this, right, this one. So this will be 84, and B over B or D, this will be 76.5. so I have, like, so you can see how many rows I have. So if you just copy and check one by one, it will take, right, a lot of time. You have like 24,000 rows. So we have to use some automatic process. And how can you do that? This is the new thing you can know. And if I want to use this condition, right, value lookup, so it is gonna look up this value D, and then where it is gonna look up from here. Okay, so from there to there. Okay, so we have to fix that. You can use the dollar symbol, then my lookup table, it will be fixed to this one. So I have fixed it. And then if I give, okay, if it will look up everything in this table from this column, the first value, it will look up the D value from A to 81.5. and if it finds, okay, D, it is messing with D, then it will replace, it will put here not D but 84. That's why I'm gonna give 2, and if it won't find anything, then it will return false. Okay, and I'm done. Okay, wait, so it will be false. It will be false. See, it already got 84, right? And if I want to repeat everything, I have to double click on that, and see, it's done. For B or D, it is 76.5, and for A it should be 49, and for C it should be 79. Let's find C. We have C, right? C for 79. Let's find A. It will be 39. For A, what is the value of that? 49. Okay, so let's find A. I can see 1A, 49. That means it is pretty, and C over D, 81.5. See, 81.5. So that means it's accurately, yeah, just looked for the value and replace this one. So we are done with this one. So what do you have to do? We have to join this table with the attribute table we have there. So we have to save this. I'm gonna copy this, and I'm gonna create another CSV file, fresh CSV file. We don't need that, we need only the values. We have this, and I'm gonna save this as a CSV file. If it is okay, then we can easily combine and join this table that we did previously, right? You can remember, if you follow everything tutorial in the first lab I did on ArcGIS, when I downloaded that NHD plus value flow line, and then I added that annual stream flow to that one based on the com ID. So that was that one. So it will be curve number calculation, and here I'm going to save that as comma delimited, and it will be curve number. Okay, so I'm going to save that, and it's there. I don't need this one anymore. I'm gonna go to my arc map, and here it is. And what I have to do, I have to add that table first, right? So here it is, I'm gonna add it. So what I have inside that one, if I open it, you can see that we have that, right? We only have these values. So hydrologic soil group and the corresponding curve number. But in that table, we have the hydrologic soil group, but we don't have the curve number. So I'm gonna copy this curve number from CN to soil, because we have other information there, and it's a map, right? So at first I have to join this to table. I'm joining this curve number table, right? I'm going to select that hydrologic soil group. Where it is, let's find that hydrologic soil group. Which one is that? Probably, yeah, let's find that name of the column, because it's a very big, okay? It's a very big hydrologic that takes time to find that. It should be not there, it should be here. Okay, that one. Okay, that one is the short name hydrologic soil group. Okay, DCD. And then we have the curve number table. We're going to join this table with the previous one, and we have the same field there. We're going to keep all record. I'm going to click OK. So the tables are joined, right? So I should do another thing before joining this one. Okay, I have to repeat the process. See, we have joined this table, but before joining that one, what I have to do, I have to remove this join first, and let me just show you that one. I'm removing this joins, but before going to joining this table, I have to add another field of curve number, because I have to copy the curve number right from that table to here. So we have to follow a specific guideline. I'm going to add a new field as curve. Okay, curve number. I'm giving the short name as curve name, and it will be double since we have a decimal degree there. So we have this. We'll fill this. We'll copy curve number from that table to here, right? That's why I'm gonna join this one. Now we have to join. We are gonna select. We have to find this value again. Don't worry, I can find it pretty quickly because I know it's there, right? It should be right there. Okay, we got it, and we have done this before. I'm gonna keep all this record. I'm gonna click OK. It's joined. Let's open the table and do the job we need. So here it is. See, at the end of the table, we can see we need which field. We need this field, right? Because this part is from that curve number table. We need to fill up this field. So if I select, and if I just right click and fill calculator, and then what we have to do, see, it's already selected soil from soil shapefile, and it selected that column name dot curve number, and I'm gonna copy everything from right, this one from curve number. See, from curve number table. So that's why the CN is the name of the table, and it's the CSV, and then we have the curve number. So if I click OK, then it will copy everything from this column to that column. See, we already have that. Can you check that? The same value. So we don't need this part. So I'm gonna remove, I'm gonna just remove the joins we have. See, that's the benefit. Remove all joins. You can see we don't have the last part of the table other than that curve number. See, we only have the curve number. So our original file is preserved. We don't need this one. We utilize that one, and we're gonna just throw it. Okay, so we're done. If I wanna show you how to even change the color, because it is not looking nice, I'm gonna change it, and based on that curve number, I'm gonna do that. Okay, I'm gonna click quantities and then graduated color, and I'm gonna select that curve number right now. And then if you wanna even what we need, don't need graduated color, we need basically different, okay, unique values. If it is unique values, and based on that curve number, it will give you an idea about, okay, I'm adding all the values we have. See, these are the values we have, and if I want to select this one, it will give you a nice map. And now you can see that here, right, you can see our curve number. These are the curve number and this part, and you can easily identify, right, these values. 84, we have 84 all these locations, and we have this one, right, 79, and that is 76, right? So we can even use this one because we have one watershed there, we have another watershed there. We can use these values, and in between these two we have mix. So it is 69 here, right? It's 69, and we have also 49. This place are not that prominent. We have very small area. So if you want to add your base map, we can do that as before, and you can complete your map as usual. That's what I already demonstrated. So that's that, right? So we are pretty good. And this map, I'm gonna even make it a little bit better than what we have right now. So I'm gonna add the north arrow first. It should be right there. If I want to expand it a little bit, what I need next step, I need to even add the scale bar as I do always, right? That is in meter, but we don't wanna do it as meter. We need to change it as miles, right? As miles, and that will be that. And if you wanna change the format, you can do that, right? You can increase the size as 12, make it bold, it will look nice. That's okay. And then if you wanna add the legend, that's what we need, which one is which, then it will give you, we don't need the title as legend, we are gonna identify which one is that. So we have pretty nice map right there. We have soil, this is 49 curve number, you can easily find out the location and area. What else we need? We need the title, right? We need the title. So curve map, okay, curve number map, curve number map of San Jacinto, right? San Jacinto watershed. Okay, we have pretty nice map, and I'm gonna copy it because I'm gonna manipulate something there. I'm gonna put it there and double click, and I'm gonna replace it. I'm gonna change the size and make it Times New Roman and bold and increase this title. You can see it's pretty nice. We have that map right there, right? We have the map, and if you want to increase the size as before, we can even do that. You can even manipulate the boundary as before we did, or you can put it this way as well, and you can save your project. You're done, right? This is what you can do. These are the steps you need to do. You can finish off here, and what I'm gonna do, I'm gonna export it. And if you wanna make this right boundary just prominent, then what we have, you can even change the point, right? Make it like 2.5, and it will be pretty nice, right? See, you can see that it will, yeah, visualize. So that's right, pretty good. What I'm gonna do, I'm gonna save the map and export the map, and it will be pretty nice. And it's gonna ask where to save. Okay, I'm gonna save as curve number calculation. That's it. We have the pretty nice map. It's exporting. The resolution is also good. And if I show you what we have here, curve number calculation, so that is the final output, right, we have for our study area. See, it's pretty nice, right? So that's that. Try by yourself and let me know if you have any problems. So what I have done today, we just calculated one model parameter. That is also the input of HKSMS model. If you select the loss method as curve number, then you have to use this curve number for your study area or for each of this sub-watershed, because you need to change this. You can't even use one value for each of them, because if your area is bigger, so it won't represent one curve number, right? Then your calculation will be wrong. And yeah, that's it. So you can try by yourself, and you can use this type of map in your report, in your paper, wherever you need. You can even do that. And you already saved your project as a single GeoGebs file, so you can even make a zip file and you can send it to your client or your teacher or any other person. Then he'll be able to open the project as it is, right? So that's that. So we are done with the calculation of curve number. And if you have any query or question, let me know, and practice. And just yeah, thanks for watching this video, and I'll just change the title in the next video, and I'll do different things. So until then, stay safe and take care. Bye.